So we were discussing about leeway. Let's watch a small video where this concept of leeway will become clear to us.
We'll first see the leeway concept and then we will move on to some other concepts which are required in attempting a day's work problem.
Let me explain about wind direction, how the naming of wind is carried out. Well, wind is named from the direction from which the wind blows. Say here, this is north, this is east, south and west, and suppose the wind is coming from this direction, so we can say that this is northeasterly wind. Let me explain about a leeway. Well, a leeway is the effect of wind in moving a vessel bodily to a leeward side. Now, you may be wondering what is the leeward side. Suppose the wind is coming from this direction and this is the vessel. Then this direction is called windward side and this direction is called leeward side. Leeway angle. This is the angular difference between a water track and the ship's heading. Suppose this is the vessel and this direction is the heading. And this is the water track. So the angle will be called as a leeway angle. Now, what is water track? Well, this is the path through the water between one position and another. Or simply we can say that this is course made good through water. Now, suppose this is a vessel and course to steer is this 090 degree true. This is course to steer, true course to steer. And suppose the wind was blowing in this direction. That means northerly wind. So the vessel is steering 090, but vessel will follow this path.
Okay, beta. So in this diagram, we can see the white color line shows us the course steered, which is 090. The yellow color dotted line shows us the actual path on which the ship is moving, which is known as leeway track. And important thing to note here is, beta, you see the course steered of the ship does not change. The course steered remains 090 only, but the vessel is actually moving on the yellow dotted track or the leeway track. Angle between these two lines is known as the leeway angle.
Vessel will be pushed bodily like this. Now we can say that there will be some angle and this angle say 10 degree. So we can say the leeway course is not 090 degree true, but it is 100 degree true. That is the leeway course. So we can say that this is expressed in degrees right or left of the true course steered. I mean the leeway angle is expressed in degrees left or right of the true course steered. However, we have some assumption. And the assumption is that the wind doesn't affect the speed of ship.
Okay, beta. So in chart work, we have this assumption that whenever the wind affects us, whenever the wind pushes the vessel, it does not affect the speed of the ship. In reality, it may not be so, because in reality, if you have a wind coming from the bow, your speed is going to reduce. And if you have a wind coming from the stern, your speed is going to pick up slightly. But whenever we consider the effect of wind in chart work, we only consider it as the leeway angle. No consideration is made in the increase and decrease of speed. So always remember this. The speed is not affected by the wind as far as chart work is concerned. Now a doubt may arise in your mind, why don't we consider it? If it is practically happening, why don't we consider it? The reason why it is not considered, or the reason why it is left, is because the effect of wind on increase and decrease of speed is a complicated phenomena. You see, how much the speed is going to increase or how much ship speed is going to decrease because of wind is decided not only by the wind speed but also by the angle at which the wind is coming to us. If it is coming from right ahead, the speed difference will be something else. If it is coming 4 points on the starboard bow, the speed difference may be something else. If it is coming from the beam, the speed difference may be altogether different. So it's a very complicated phenomena and it is very difficult to estimate. So that's why it is left untouched in chart work problems.
In reality, definitely the speed of the ship is affected by the wind, especially if the wind is blowing from ahead or from astern.
So till now we have seen the leeway angle. We know now if the leeway angle is given to us, how can we find out the leeway track? Now in the questions, what they give us is, they will tell us the course steered by the ship and they will tell us the wind direction. Now we will have to find out whether leeway angle has to be added or leeway angle has to be subtracted from the course to get the leeway track. Let's say in this particular condition, so the ship was moving on a easterly track, easterly course. The wind is northerly wind, so leeway angle is 10 degrees. Now in this case, we know that to find the leeway track, we will have to add this angle to the course steered. So 90 plus 10 will give us the leeway track, which is 100. Now beta, in the same scenario, if the wind was not northerly wind but southerly wind, so in that case, can you tell me what will be the leeway track?
080, sir.
080.
Very good. So if the wind was southerly wind, so you see we will have to subtract this leeway angle from the course steered to get our leeway track. So it will be 90 minus 10, that is 80. So in all the questions, we will have to make a rough diagram where we will draw the course steered, we will draw the wind direction, and from there we will have to find out whether the leeway angle has to be added or subtracted to get the leeway track. Leeway track is what is used to find the departure and delat, because leeway track is the one where the ship is actually moving. So this is what is required in the questions. Now the further explanation which you see in the video is not required in chart work problems, but if somebody asks you in orals that, let us say your ship is steering a particular course, there is strong wind in that area, how are you going to estimate the leeway angle? So then you can use this technique to answer it. So in chart work problems, this is not required to be done, because in chart work problems, the leeway angle is straight away given to you in the question itself. So now you can see how can we estimate the leeway angle when we are on the bridge and the vessel is getting affected by the wind.
Now let's find out some method to estimate leeway. Well, we can estimate the leeway by looking at the wake of ship. And what is wake of ship? It is a trail left astern of the ship. Suppose this is the vessel, and astern of the ship there is a trail on water. So this is called wake. This is a fore and aft line, and this trail will make some angle. This angle is leeway. Let's do this example. Suppose wind direction is 300 degree true and the true course is 215 degree true and the leeway, estimated leeway is 5 degree. So let's make this 000, this is 090, this is 180, this is 270, and the wind is coming from 300. So this angle is 300. Well, ship is in this direction and the true course to steer is 215.
Beta, can you tell me what will be the leeway track?
210, sir.
Very good, beta. It will be 210 because you see from the diagram, to find the leeway track, we will have to subtract the leeway angle from course steered. So 215 minus 5, it will give you 210 degrees as your leeway track.
215. The true course to steer is 215 here. Now, wind is pushing in this direction, so this will be the leeway course. And if this angle is 215, so from here to here is 215, and the leeway, estimated leeway is 5 degree, that means this course is going to be 210. This course will be 210.
Okay. So I hope leeway is clear to everyone now, beta. Any doubts or queries you have in leeway?
Okay. So next thing which we have in day's work is the effect of current. So the direction in which the current is flowing is called as a set of the current. Okay. So it is not called the course, it is not called the direction in which the current is going. It is called as the set of the current. So in any question, if they use the word set, it basically tells you the direction in which the current is flowing. The speed with which the current is flowing is called as the rate of the current. So if they say the rate of the current is 2, that means the current is moving with a speed of 2 knots. So rate is basically the speed of the current. Now, the distance which the current has taken the ship along in a certain time interval is called as the drift of the current. It is known as the drift of the current. So direction is known as the set, the speed is known as the rate, and the distance the current has pushed us in a particular direction is known as the drift. So either in the question they will give you the set and rate, and they will tell you the time for which the current was affecting us, or they will give you the set and drift of the current. So if the set and drift is given, then time is not required. The set and drift can be used as a course and distance. Now, when we do the day's work calculation, if there is a current prevailing in that area, now how do we account for that current? The set of the current is taken as a course and the drift is taken as a distance. So let us say you are proceeding on your passage from day 1 to day 2 and you are going like this. These are the different courses which you steered. And let us say there was a current prevailing in that area. What was the current? The current was prevailing in this particular direction, like this. And they told you that the current was affecting the ship for full 24 hours. Now, how do you account for this current? Now, this current can be applied as a course and distance vector. So you can apply this current here. Okay. You can apply it anywhere. You want to apply it in the beginning, it can be applied in the beginning. At any intermediate point, it can be applied there. Because all these courses and distances and the current are like vectors. In whichever order you add the vectors, the resultant is going to be the same. So usually it is applied at the end. So we apply the current at the end. The set of the current is taken as a course and the drift of the current for the full time interval. If it is there for 24 hours, let us say the current is applicable for 24 hours and the rate of the current is 2 knots. the drift will be 48 miles. So we will take the length of this vector as 48 miles. This 48 miles will be taken as a distance. And whatever is the direction of the current, that is the set of the current, let's say it is 135, that 135 is taken as a force and it is applied as usual. So this is how the current is applied in day's work calculations. Okay, beta. Now let's go to the next concept. The next concept is log readings. So as I told you that sometimes in the question, instead of giving you the distances on each leg, they will give you the readings of the log. So if these log readings are given to us, we can use these log readings to find out the distance steamed. So sometimes instead of speed, log readings, that is the distance covered, are mentioned at the beginning, at the end of the hose. Now the distance steamed on each leg is obtained by finding the difference of log readings taken at the beginning and at the end of each course. Let us say you were moving on a particular course. When you started moving, the log reading was 1110, and when you ended on this particular course, the log reading was 1136, 1136.5. Okay, so what will be the distance covered on this leg, beta?
26.5.
Very good. The distance covered would be 26.5. So sometimes we are provided with log readings. So this is how we find out the distance steamed on particular legs. Okay. So let's go to the next concept now. The next concept is, which is sometimes used in the day's work questions, is advancing and retarding of the clocks. Now, when the ship is moving on its passage, the ship goes from one time zone to another. So we need to advance or retard our clocks. Now, whenever advancing and retarding is done, if it is mentioned in a day's work problem, we have to consider this advancing and retarding for calculating the distance covered on a particular leg. So let us say you are going from point A to point B. Okay, moving like this. Let's say they tell you started off from point A at 1200 hours and you reached at point B at 1600 hours. Now during this interval, the clocks are advanced by half an hour. We have advanced the clocks by half an hour or 30 minutes. Okay. Now, can you tell me, beta, what will be the total time from position A to position B?
3 hours 30 minutes.
Okay, one option is 3 hours 30 minutes. Anybody has a different answer?
Two hour 30 minutes.
Okay, so second option is 2 hours 30 minutes. So option A 3 hours 30 minutes, option B 2 hours 30 minutes. कौन बनेगा नेविगेटर?
No, sorry, 3:30, sir. 3 hours 30 minutes.
Okay, all right. Beta, just give me 1 minute. Okay, beta. Sorry for the interruption. So, clocks are advanced from A to B.
Advancing and retardation of the clock, the effect will be on the current, no sir. अगर current एडवांस है 1 घंटा के लिए तो करंट तेज 23 आवर्स के लिए लेंगे, और अगर रिटार्डेड है तो फिर 25 आवर्स के लिए लेंगे. तो डिस्टेंस मतलब ए पॉइंट से बी पॉइंट में जो करंट है उसके ऊपर इफेक्ट करेगा ना सर.
राइट बेटा, ये करंट के ऊपर भी अफेक्ट करेगा. और अगर आपको स्पीड दे रखी है, लेट अस से उन्होंने आपको स्पीड दे रखी है, वेसल वाज मूविंग विद ए स्पीड ऑफ 10 नॉट्स. ओके, तो आप जब डिस्टेंस निकालोगे उस पे भी इसका अफेक्ट आएगा, दोनों पे इसका अफेक्ट आएगा. ओके, लेकिन ये अफेक्ट हमें पता कैसे चलेगा? हमें सबसे पहले तो ड्यूरेशन निकालनी होगी कि ए से बी जाने में हमें कितना टाइम लगा है. 3 आवर 30 मिनट लगे हैं या 2 आवर 30 मिनट लगे हैं. Once we know the duration, then we can find the effect of this advancing and retarding on the distance covered as well as on the drift of the current. Right? तो
Yes,
अब बेटा हमने क्लॉक्स को एडवांस कर दिया है आधे घंटे के लिए. तो टोटल टाइम ए टू बी, लेट अस से ए पे मैंने स्टॉप वॉच ऑन की और बी पे मैंने स्टॉप वॉच को बंद कर दिया. तो टोटल टाइम स्टॉप वॉच कितना दिखाएगी? 2 आवर 30 मिनट दिखाएगी या 3:30 दिखाएगी?
3:30.
ओके, सो बेटा एडवांसिंग का मतलब क्या है? एडवांसिंग का मतलब है, लेट अस से कि हमने 1400 पे एडवांसिंग की, बिल्कुल बीच में. एडवांसिंग का मतलब क्या है? जब 1400 बजेंगे तो हम क्या करेंगे बेटा? घड़ी को आगे करेंगे या पीछे करेंगे?
14:30 कर देंगे सर.
तो आपने 1400 पे क्लॉक को 14:30 कर दिया, राइट? तो अब बताओ बेटा कि ये आधा घंटा कम हो गया या ज्यादा हो गया?
वॉच तो पहले से ही एडवांस है ना, तो 1400 अगर है और वॉच ऑलरेडी एडवांस है तो मतलब हम लोग आधा घंटा आगे चल रहे हैं, तो उसको हमें पीछे करना पड़ेगा सो दैट वी कैन मीट द टाइम.
बेटा पहले से ही एडवांस नहीं है, एडवांस हमें क्लॉक को करना है और हम उसे 1400 पे कर रहे हैं. क्लॉक तो नॉर्मल तरीके से 1200 से चल रही है. 1200 बज गए, 1300 बज गए, 1400 जैसे ही बजे अब हमें क्लॉक को एडवांस करना है. हम करेंगे क्लॉक को एडवांस. कितना एडवांस करेंगे? 30 मिनट करेंगे. क्यों करेंगे? क्योंकि हमारा शिप टाइम जोन चेंज कर रहा है, हमें टाइम को आगे लेके जाना है. तो हमने 1400 पे क्लॉक की सुई को आगे घुमा दिया और 14:30 टाइम कर दिया. इसे हम बोलते हैं एडवांसिंग ऑफ क्लॉक, राइट? अब मुझे ये बताओ कि 1200 टू 1600 के इस पूरे इंटरवल में हमारी स्टॉप वॉच 2.5 घंटे दिखाएगी या 3.5 घंटे दिखाएगी?
3.5 घंटे सर.
ओके बेटा, 1400 पे आपने घड़ी में 14:30 बजा दिए, तो जो 30 मिनट का इंटरवल था वो 0 हो गया ना. 1400 पे आपने घड़ी आगे करके 14:30 कर दिए, तो जो 30 मिनट का ये टाइम पीरियड था ये 0 बन गया.
यस सर.
अगर ये 30 मिनट का टाइम इंटरवल 0 बन गया है तो टाइम कम हुआ है या ज्यादा हो गया है?
कम हो गया सर.
कम हो गया सर.
कम हुआ सर.
राइट, वेरी गुड. सो टाइम पीरियड कम हुआ है. तो सॉरी, ये 2:30 नहीं है बेटा, 3:30 और 4:30 था, माय मिस्टेक. So 330 hours will be the duration of time between 1200 and 1600. So whenever clocks are advanced, the advancing time is reduced from that lag time. अब बेटा मुझे ये बताओ कि अगर हम क्लॉक को रिटार्ड कर देते, 30 मिनट रिटार्ड कर देते क्लॉक को, ओके, 1400 पे हमने वापस से इसे 13:30 कर दिया, ओके, तो इस केस में बताओ हमारी इस लेग पे टोटल टाइम कितना होगा?
4 hours 30 minutes.
Very good. So if clocks are retarded, that much time is added to that lag time. So this is also clear now beta, advancing and retarding of clocks.
Yes sir.
Okay, very good. So always remember, if there is a advancing, that much time should be reduced from the lag time. If there is a retardation, that much time should be added to the lag time. अब जब आपके पास lag का टाइम आ गया, अब बहुत आसान है डिस्टेंस को निकालना, क्योंकि टाइम आपके पास आ गया है, आपको स्पीड पता है, स्पीड इनटू टाइम जब आप करोगे तो आपको उस पर्टिकुलर leg का डिस्टेंस पता चल जाएगा. So that is the concept of advancing and retardation of the clocks. Okay, so जो भी concept phase work की problems में लगते थे वो more or less अब हमने discuss कर लिए हैं. So let's now go into a practical days work problem and see how all these things are used. So हम अब एक days work का question यहाँ पे देखने वाले हैं. So one question I will show you here, and the second question you will be doing it on your own. So we will practice. So this question says, at noon on 14th September, a ship is in this particular position, 4012 north, 07646 west. It set a course of 250 compass. Deviation is given to us, variation is given to us, at an engine speed of 16 knots. Now this continued till 1600. At 1600, the course is altered to 287. The deviation is 2 degrees east now, and variation is 6 degrees west. And at 1600, the speed is also reduced to 14 knots. This continues till 2200 in the night. So at 2200, the course is now altered to 340 compass. The deviation is 5 degrees east, variation is 5 degrees west, and the speed is maintained 14 knots. This continues to 0600 on the next day. At 0600, the course is altered to 277, deviation 2 degree west, variation 5 degree west, speed is 15 knots till the next day, noon. So these are all the courses and speeds maintained by the ship from one day noon to the next day, noon. So this is how the question will be given to us in a textual format, in a text format. So they want us to find the estimated position on 15th noon, the course made good and the distance made good, if the current was setting 027 at 2 knots throughout. So we need to find out what is the position arrived on 15th, our EP, the course made good and the distance made good. They have also given us the current. करंट का सेट है 027 एंड करंट का जो रेट है वो है 2 नॉट्स. तो लेट अस प्रोसीड स्टेप बाय स्टेप. इस क्वेश्चन में हमें कैसे प्रोसीड करना है. देखो जो पहला स्टेप है बेटा, इन्होंने हमें क्वेश्चन में कंपास कोर्सेज दिए हैं. तो वी विल हैव टू कन्वर्ट दोज कंपास कोर्सेज टू ट्रू कोर्सेज एंड ट्रू टू क्वाड्रेंटल नोटेशन. So let's do that. Let's make a table where we can do this conversion. So हमने बेटा ये एक टेबल बना दिया. इस टेबल में सबसे ऊपर हमने लिखा यहाँ पे टाइम. So you have 1200 to 1600 one leg. Then 1600 पे कोर्स ऑल्टर किया हमने up to 2200. This is our second leg. Then 2200 to 0600. This is the third leg. 0600 to next day noon. This is the fourth leg. And they have given us the current also for full day. So as I told you, the current is taken as a course and distance. So this is our fifth leg of the passage. So what we do is, first of all, we write the compass course by the ship which is given to us. So हमने सारे compass courses note कर लिए. 250, 287, 340, 277. Then we use the CDMVT. Next what comes is the deviation. 4 degree west, error west, compass west. So that means we will have to subtract the deviation. So we get magnetic course 246. Here it is 2 degree east, error east, compass least. So we add it and we get the magnetic course as 289. Error east, sorry, deviation east, compass least. So 340 plus 5, this gives us the magnetic force as 345. Again, you have deviation west, compass west, and we get the magnetic course as 275. So हमें सारी की सारी legs पे magnetic courses मिल गए हैं. Now we apply the variation. So you have 6 degree west, 6 degree west, 5 west, 5 west. We apply the variation and we get the true courses. हमारे पास चारों legs के true courses आ गए हैं. The set of the current is given in true notation, so that is also written here. So we convert this true course into the quadrantal notation now. So 240 becomes south 60 degree west, north 770 west. Then you have 340 as north 20 west. And you have 270 as a westerly course. 270 जो course है बेटा ये westerly course है. If it is 090 it becomes easterly. If it is 000 it becomes northerly. If it is 180 it becomes southerly. So current becomes north 27 east. Now second thing beta, they have given us the speed on each leg. So हम उस speed के साथ अपना distance covered निकालेंगे and we will write the distance here. So first leg speed is 16 knots and the leg is for 4 hours. So the distance comes to 64 miles. Second leg 14 knots, 6 hours, it becomes 84 miles and so on. 112 miles, 90 miles. Current का जो rate है वो है 2 knots and it is applicable for full 24 hours. So 24 into 2 it becomes 48 miles. So सबसे पहला step तो ये है बेटा कि हमने सारे के सारे courses को कंपस से ट्रू और ट्रू से क्वाड्रेंटल नोटेशन में कन्वर्ट किया and we have written down the distance on each of the legs. So up to here beta, any doubt anybody is having?
No sir.
It's all clear beta?
सर एक बार आप रिपीट कर सकते हो सर जो करंट का है वो कैसे लेना है सर पूरा ओवरऑल?
ओके बेटा, तो फर्स्ट लेट मी टेल यू कि ये लेना कैसे है. ये देखो मैंने जो करंट वाला आपको दिखाया था, व्हाट इज रिटन हियर, इन डेज वर्क कैलकुलेशन द सेट current is taken as a course and the drift of the current is taken as a distance. तो हमने करंट का जो सेट था उसे अपना कोर्स माना और जो ड्रिफ्ट था उसे अपना डिस्टेंस माना. राइट बेटा, अप टू हियर ओके?
यस सर.
अब देखते हैं इस क्वेश्चन में उन्होंने करंट क्या मेंशन किया है. सी, इफ यू सी हियर they have mentioned the set of the current is 0 to 7. So this becomes our course and the rate of current is 2 knots. ये तो है rate, हमें चाहिए drift. तो अब ये 2 knots कितनी देर के लिए लग रहा है? इन्होंने यहाँ पे लिखा है throughout. Throughout का मतलब है noon से लेकर next day noon तक. Okay? So next day noon, okay, till noon, next day noon तक. So noon to noon ये total time हो गया 24 hours. यहाँ पे कोई advancing और retarding of the clock नहीं थी, तो ये 24 hours है. अगर कोई advancing retarding होती तो ये time 24 से ज़्यादा या कम भी हो सकता था. So since the time is 24 hours, speed is 2 knots, तो हमारी total drift कितनी बन गई बेटा?
48. ठीक है सर, समझ गया. थैंक यू सर.
48. So 0 to 7 is our course and 48 mile is our distance. Now you look in the table, 0 to 7 is our course and 48 miles is our distance. ओके, और कोई डाउट आ रहा है बेटा इस टेबल को बनाने में, किसी भी पॉइंट पे? एनी डाउट? वेरी गुड बेटा। तो वंस यू हैव दिस टेबल, अब इस टेबल की जो नीचे वाली दो वैल्यूज हैं बेटा, ये दो वैल्यूज जो मैंने अभी ग्रीन कलर में बॉक्स बना दिया है, दैट इज द क्वाड्रेंटल कोर्स एंड द डिस्टेंस। इन दोनों को अब हमने आगे यूज करना है। तो वी विल बी यूजिंग दीज वैल्यूज टू फाइंड आउट फर्दर आंसर। तो इन दोनों को हमने अपनी नोटबुक में नोट कर लेना है, टेबल हमारी नोटबुक पे बन जाएगा। तो these two values will be picked up now. So we will be using these values in the next calculation. So I am going over to the next slide now. अब बेटा हम एक दूसरा टेबल बनाएंगे। ये सेकंड टेबल हमारे पास आ गया। इस सेकंड टेबल में हमने जो दो वैल्यूज निकाली थी, एक हमने निकाला था कोर्स और दूसरा निकाला था डिस्टेंस। उनको हम ये पहले वाले दो कॉलम में लिख देंगे। ओके, पहले दो कॉलम में। इफ वी गो बैक टू द स्लाइड, यू सी पहली लेग थी हमारी साउथ 60 वेस्ट एंड 64 माइल। इफ यू सी इन दिस टेबल, हमने यहाँ पे साउथ 60 वेस्ट और 64 माइल ये दोनों लिख दिया है। ये कोर्स है, साउथ 60 वेस्ट कोर्स है और 64 माइल डिस्टेंस है। अब हम क्या करेंगे, हम इस कोर्स और डिस्टेंस से निकालेंगे डी लैट एंड डिपार्चर। अब बेटा जो डी लैट है इसे हमने दो पार्ट में डिवाइड कर दिया। नॉर्थ वाला डी लैट जो है ये हम लेफ्ट साइड कॉलम में लिखेंगे, साउथ वाला डी लैट राइट साइड कॉलम में लिखते चले जाएंगे। अब बेटा आप मुझे ये बताओ, इफ योर कोर्स इज साउथ 60 वेस्ट, व्हाट विल बी द डायरेक्शन ऑफ द डी लैट?
Southerly.
वेरी गुड, इट विल बी सदरली। दैट्स व्हाई यू सी मैंने ये जो डी लैट लिखा है ये सदरली के नीचे लिखा है। ओके, और डी लैट निकलेगा कैसे? डी लैट इज इक्वल टू डिस्टेंस कॉस कोर्स। So you can check it in your calculators. 64 cos 60, ये आंसर आएगा 32। राइट बेटा, डीलैट आ गया?
यस।
ओके, अब बेटा नेक्स्ट चीज जो निकालनी है वो है डिपार्चर। अब इस केस में हमारा कोर्स वेस्टर्ली है, साउथ 60 वेस्ट, तो हमारा डिपार्चर भी वेस्टर्ली होगा। तो मैंने डिपार्चर के दो कॉलम बना रखे हैं, ईस्ट और वेस्ट। आई विल राइट अंडर द वेस्ट कॉलम। और डिपार्चर का फॉर्मूला क्या होता है? डिस्टेंस साइन कोस। तो इट विल बी 64 साइन 60। जैसे ही आप ये करोगे तो आपको अपना डिपार्चर मिल जाएगा 55.4 मिनट्स वेस्ट। तो हमने डिपार्चर को भी नोट डाउन कर लिया। तो अप टू हियर क्लियर बेटा?
Yes, sir.
ओके, वेरी गुड। तो अब बेटा हमें हर एक लेग पे यही काम करते चले जाना है। ये हमारी सेकेंड लेग आ गई, हमने सेकेंड लेग का कोर्स और डिस्टेंस लिखा, इसका डीलैट निकाल लिया और डिपार्चर निकाल लिया। इसको हमने जो कॉलम था उसी कॉलम में फिलअप करते चले गए, रिस्पेक्टिव कॉलम में हम इसे फिलअप करते चले गए। थर्ड लेग के साथ भी हमने यही किया। देन फोर्थ लेग आ गई हमारी। अब बेटा फोर्थ लेग में हमारा कोर्स है वेस्टर्ली। ओके, अब वेस्टर्ली कोर्स का मतलब है कि हम लोग पैरेलल सेलिंग कर रहे हैं। इफ वी आर मूविंग इन द वेस्टर्ली डायरेक्शन, वी आर मूविंग अलोंग द पैरेलल ऑफ ए लैटिट्यूड। जब हम पैरेलल सेलिंग करते हैं तो जो हमारा डिपार्चर होता है वो होता है
Distance.
डिस्टेंस। तो जो डिस्टेंस हमने कवर किया है, ये 90 माइल का डिस्टेंस हमने कवर किया है, यही डिस्टेंस हमारा डिपार्चर होगा। दैट इज व्हाई यू सी हमने यहाँ पे वेस्टर्ली डिपार्चर के नीचे 90 लिख दिया है। इफ यू गो इन द ईस्टर्ली और वेस्टर्ली डायरेक्शन, तो जितना डिस्टेंस आप कवर करोगे आपका डिपार्चर बिल्कुल उतना ही हो जाएगा। ओके, So that is why the departure is 90. और अगर आप बेटा नॉर्थ या साउथ कोर्स पे चल रहे हो, नॉर्थ या साउथ कोर्स पे अगर आप चलोगे तो जितना डिस्टेंस आप कवर करोगे उतना आपका डीलैट हो जाएगा. When you are moving on northerly or southerly courses, dlat will be equal to the distance covered. Okay? नॉर्थ साउथ कोर्स पे डिपार्चर 0 होता है. There is no D-long, there is no departure. ईस्ट वेस्ट कोर्सेज पे डीलैट 0 होता है बिकॉज वी आर मूविंग अलोंग द पैरेलल ऑफ ए लैटिट्यूड. तो यू सी इसमें हमने कोई भी डीलैट नहीं लिखा बिकॉज हम वेस्टर्ली डायरेक्शन में चल रहे हैं. तो देन कम्स द नेक्स्ट लेग, नॉर्थ 27 ईस्ट वाली लेग आ गई. ये हमारा करंट वेक्टर है. करंट वेक्टर के साथ भी हमने बिल्कुल कोर्स और डिस्टेंस के जैसे ही डीलैट और डिपार्चर को निकाल लिया. तो वी हैव द डीलैट एंड डिपार्चर ऑन ऑल द लेग्स नाउ. अब हमने क्या किया बेटा, यहाँ तक हमारे पास सारे डीलैट और डिपार्चर आ गए. हमने अब नॉर्थ वाले डीलैट को ऐड कर लिया, साउथ वाले डीलैट को भी ऐड कर लिया. नॉर्थ वाला डीलैट आया 166.9, साउथ वाला डीलैट आया 32. अब इन दोनों में से बड़ी वैल्यू 166.9, इसमें से छोटी वैल्यू को हमने माइनस कर दिया. So 166.9 minus 32, this gives us the answer DLAT 134.9. और इसका नाम हमने क्या रखा, जो भी बड़ी वैल्यू का नाम था, इस केस में बिगर वैल्यू इज हैविंग नॉर्थ नेम, तो हमने DLAT को अपना नाम नॉर्थ दे दिया. सेम थिंग डन विद डिपार्चर, ईस्टर्ली डिपार्चर, वेस्टर्ली डिपार्चर. वेस्टर्ली इज बिग, so west minus east 265.5 minus 21.8 gives us 243.7 westerly departure. तो हमारे पास ये resultant DLAT और resultant departure आ गए. Now once we have these resultant DLAT and departure, we can easily calculate our final position as well as the course made good and distance made good. Okay? तो अब बताओ बेटा, पहले तो डीलैट और डिपार्चर निकालने तक कोई डाउट आ रहा है? रिजल्टेंट डीलैट एंड रिजल्टेंट डिपार्चर वी कैन कैलकुलेट.
यस सर.
वेरी गुड. अब बेटा जैसे ही ये दोनों हमारे पास आए, वी हैव द डिपार्चर, वी हैव द डीलैट. नाउ इट इज वेरी इजी टू फाइंड आउट द फाइनल कोर्स. ये जो डीलैट है बेटा, इस डीलैट को आप अपने इनिशियल लैटिट्यूड में अप्लाई कर दो. इनिशियल लैटिट्यूड इज गिवन टू अस इन द क्वेश्चन, यू सी 40 डिग्री 12 मिनट्स नॉर्थ. अगर हम इसे इनिशियल लैट पे अप्लाई कर दें तो हमें हमारा फाइनल लैटिट्यूड मिल जाएगा. सो यू अप्लाई दिस डीलैट टू द इनिशियल लैटिट्यूड, यू विल गेट योर फाइनल लैट. तो हमारे पास फाइनल लैटिट्यूड आ गया. Now when you have the initial latitude and final lat, तो हम mlat भी निकाल सकते हैं. हमारे पास mean lat भी आ गया, right? Now when you have mean lat, okay, so you have the departure. You can find out the d-long also. Departure is equal to d-long into cos of mlat. So from this departure and from the mlat, we find out the d-long. When we apply this d-long to the initial longitude, it gives us the final longitude. So it gives us the final longitude. Right, beta? So final position हमारे पास आ जाएगी. Just give me 1 minute. You can. So is it clear beta up to here? Finding the final position. It is exactly similar to a plane and parallel sailing problem. वहां पर भी हमने डीलैट और डिपार्चर निकाला था और उसी से इनिशियल पोजीशन में अप्लाई करके फाइनल पोजीशन फाइंड आउट की थी. सो एग्जैक्टली सेम प्रोसेस. Okay, all right. So that tells me it's clear. So let's go to the next thing now. They want us to find out the course made good and the distance made good. So beta, can you tell me how can we find out the course made good from here?
सर जो हमारा फाइनल प्लेन सेलिंग वाला ट्रायंगल बनेगा उससे वी नो द डिपार्चर एंड डीलैट so we can calculate the course.
Very good, beta. So using the same formula, tangent course is equal to departure upon DLAT. हम ये resultant departure और resultant DLAT को use करेंगे और हमारे पास हमारा course made good आ जाएगा. And how can we find out the distance made good, beta?
By departure formula.
ओके, अब डिस्टेंस के लिए दो फॉर्मूले हैं बेटा, एक डीलैट का फॉर्मूला भी यूज कर सकते हैं और डिपार्चर का भी कर सकते हैं. विच वन विल यू यूज?
सर डीलैट.
हाँ, ऑलवेज रिमेंबर बेटा, हमने उस टाइम भी डिस्कस किया था, फॉर फाइंडिंग द डिस्टेंस ऑलवेज यूज द डीलैट फॉर्मूला, डोंट यूज द डिपार्चर फॉर्मूला. मैथमेटिकली उसे भी यूज किया जा सकता है, देयर इज नो प्रॉब्लम, but navigation में fundamentally we always use the DLAT formula for finding the distance. So we can find out the course made good, the distance made good from noon to noon and also the position arrived. तो अब बेटा ये वैल्यूज तो आपके पास आ गई हैं, आप अपनी नोटबुक्स में इसको सॉल्व करो और ये चारों चीजें निकालो, कोर्स मेड गुड, डिस्टेंस मेड गुड एंड द पोजीशन अराइव्ड. ये चारों चीजें आपने अभी निकालनी है बेटा. Okay, so anyone did it beta?
Sir course
Got the latitude, sir.
north 61 degree 02 minute. Yeah, west.
सही है सर.
Distance made good 278.5. This is the position arrived. Okay beta, so with this basically our session is complete. Okay, so beta, now you can practice these days work questions which are given in the book, practical navigation book. So there are about 7-8 solved examples which are given, no exercises there. So please try out those solved examples and you should be able to do all those questions. Whatever concepts were there, we have already discussed them in the class. So when you apply these concepts, you should be able to find the answers to all those problems. So please practice these questions. Any doubts you are having, we will sort them out in the next class. So please ensure that you practice these, because unless you practice, they will not get strengthened in your mind. So that's all for this class. See you in the next class, beta.
Take it like it. Take it like it. Do it, make it. Do it, make it. Take it like it.